Day 54 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. This time we're at day 54. I'm glad you guys are still with me. I'm glad we're still going. We're still learning. You know, you can never learn too much. You should never stop learning. There's always something new to learn, which is why we're learning every day. And we're on day 54 of this LeetCode learning journey. And I'm glad you guys are here with me to embark on this journey with me. Now, with that being said, guys, don't forget, bring a mouse, bring a mouse, bring a mouse, bring a mouse right over here, guys, and go ahead and click that subscribe button, guys. And after you click that subscribe button, go ahead, hit that smash that like button for me, guys. Then after you smash that like button, go ahead, go right into the comments and go ahead, drop that bank emoji in the comments. All of my bankers out there, go ahead and drop a bank emoji in the comments so we can continue to grow this community, grow this Swift community, grow this YouTube channel, and just grow as a person and grow in life, guys. So I appreciate the help. I appreciate you guys learning with me, and let's see what the problem says today. Today we have question number 199, binary tree, right side. This is the first question in the BFS binary tree part of the LeetCode 75 study plan. That's the breadth first search, and the difficulty level is medium. So we're not gonna let that deter us, guys. We're still gonna knock this question out, even if it is medium, and we're still gonna keep the solution as easy and simple to understand, so we all can learn and we all can gain something from this video that we're making today. Because remember, guys, the goal is to learn something, and so we're gonna keep the solution understandable so everybody can learn, because we're all on different levels of our learning journey in LeetCode and data structures and algorithms. So, with that said, let's see. It says, given the root of a binary tree, imagine yourself standing on the right side of it. Return the values of nodes you can see ordered from top to bottom. Example 1. So we have the input, the root, list of tree nodes, boom, boom, boom. Then the output would be 1, 3, 4. That is because you have the 1, 3, and the 4 on the right side of the tree. And imagine, like I said, we have to imagine a person is standing. It says right here, imagine yourself standing on the right side of it. Return the values of the nodes you can see from top to bottom. So a lot of people might just wonder, well, let's just go down the right side and list all the nodes. However, that could get confusing, and that may not give the correct answer, guys, because say we had the same tree, right? But say 5 has some children nodes. Say the node could be on either side, left or right, right? Say that node, we could just put that node as 7. Say it's a 5 has a children node called 7. Technically, if we're standing right here on the right side, we would still be able to see that node 7 because there's no node blocking it right here. Whereas on these 3 nodes, 1, 3, 4, they are blocking 2 and 5. So if we were standing right here, we would not be able to see 2 and 5 because 3 and 4 is in the way. However, if 5 had a child node and 7 was right here, there would be nothing blocking it. So if we were standing on this side, we would still be able to see it, and we would have to include it in our list of nodes, which is why we cannot just come down the right side like we would normally do. So with that being said, let's look at example 2. It says input root, got the list of nodes, output is 1, 3. Example 3 is just an empty array. Output is an empty array. So let's see, guys. Let's break this down. Now, I hope you guys, I went over this in a previous video, but I hope you guys understand what this list of nodes means. So if you look, we have the 1 right here. Then we come down, we have the 2 and the 3. Then we come down again so we're going to the child nodes. Now we're coming down to 2 child nodes. First, let me start off. We have the 1. We come down to 1 child nodes. 1's child nodes is 2 and 3. Boom. Then we come over to 2. We go down to 2's child nodes. This is the null. That's where the null come from. Null and 5. Those are 2. The null and 5 represents the 2's child nodes. So null and 5. Then the same thing for 3. Now we're doing 3's child nodes. Null and 4. In case you're confused, that's where the null come from, because there is no child node right here, so we put null, then we put 5, then we come over here, there's no child node right here, so we put null, then we put 4. Just some extra knowledge to give y'all in case y'all missed the last video where I went over that. Now, let's see how we're going to solve this problem. Problem's actually not that difficult, and you guys already know we're going to keep the solution simple and easy to understand. So first thing we're going to do is we're going to declare a variable called nodes, and we are going to cast that as an array of tree nodes. Then we're going to initialize it with a blank array. Then we're going to declare another variable called result, and that is going to be cast as an array of integers. We're going to initialize it with a blank array. Excuse me, guys. Then we're going to come down here and we're going to say if let root equals root, we are going to nodes dot append their root. Else, we're going to return a blank array. Then we're going to come down here underneath that if let statement, and we're going to say while, we're going to put exclamation point nodes is empty. So basically what that says, if nodes is not empty, that's what the exclamation point is for. We are going to say let temp equal nodes, and temp is going to hold that value for nodes, and then we're going to set nodes as a blank array. But don't worry, because temp is holding the original value. Then we're going to come down here and we are going to say if let last equals temp dot last. We are going to come down here and we're going to say result dot append last dot val. Right? Then we're going to come down here underneath that if let statement, and we're going to create a for loop, and we're going to say for node and temp, because remember guys, temp is holding the value of node. So we're going to say for node and temp. We are going to say if let left equals node dot left. Then we are going to say nodes dot append left. Now I'm sure you guys know what comes next, what we're doing after this. If you've been keeping up with the channel, what do you think we're doing next? You guessed it, we're going to do the same thing for the right side. So we're going to say if let right equals node dot right, then we're going to say nodes dot append right. Then we're going to come all the way down here, right here, and we're going to say return result, guys. And that should be all she wrote. So let's run it and see what happens. Boom, it's accepted, guys. So go ahead, get the code, look at the code one more time before I submit it. Get that good code for you, and now let's submit it. Let's see what it says, guys. 4 milliseconds beats 45.18% of users with Swift, guys. Not too bad at all. Remember, we're still learning. We're going to get these numbers up as time goes along, but right now, we're just going to learn and learn as best as we can, which means we got to make the solutions as easy to understand so we can soak in all that knowledge and that understanding and apply that to questions that we have in the future. So with that being said, guys, that's all for today. I'll see you guys tomorrow. See you later.